Hello, everyone. Good morning, good evening, good afternoon, based on the time zone or recording if you're watching it. My name is Victor Monga. I'm part of Cloud Security Alliance and Virtue Testing. Today's session is presented for Cloud Security Alliance LA chapter by Virtue Testing. Today we have our host, Drew and Simone. They will be talking about healthcare IoT and the security focused on that.
Hello, thanks for having us, Victor.
Of course. So guys, if you would like to get an access to this deck and the recording, please go ahead and scan this QR code on your on your screen. Make sure you are following our LinkedIn, Twitter, YouTube channels so you have access to it. So today we have a big announcement. CSA LA chapter is forming a study group for CCSK certification. And we will start a study group for 6 weeks starting June 1st, 2020. We have a big announcement. If you actually join our study group, and the first 10 names will be getting our free CCSK online training. And the cost of that training is about $450 usually. But if you go in and submit your name to that Google form, we'll make sure that you are eligible, and they will verify that, and we'll get you a free license. Now, if you don't remember or if you don't have access to our deck, how are you going to get this Google form? Again, not to worry. Make sure you're scanning those QR codes and you're following our LinkedIn, Twitter, and YouTube. All of these links will be posted over there as well. So even if you don't get a chance to take a picture right now, just make sure you're following our social media. If you have any additional questions, please send that to our email address, learn@csala.org. We'll make sure to answer those momentarily. With that, we'll start our today's journey. So as I said, we have Drew and Simone. They're going to be talking about the healthcare IoT. With all this going on with coronavirus and COVID-19, we are making sure that everybody is still vigilant about healthcare IoT security, and we're doing our best to make sure that you guys are understanding the landscape and how it's evolving. A little bit about Virtue Testing, based out of California, a nonprofit organization. It's focused on cybersecurity education and fiscal sponsorship. So our goal is to provide fiscal sponsorship to those groups who doesn't have ability to take tax writable or tax deductible fiscal sponsorship or donations. A little bit about our community services. As I said, we focus on education, we focus on our charity. We also provide testing to security solutions that our partners are collaborating with us. So if you want to know more about those things, again, send an email to us, connect with us. We'll get you part of that working groups and make sure you have access to all of those cool tools that we're working on. A couple of projects that we're working on. One is VMware networking. That is software-defined networking. So if you want to know more about it, how virtual packets flow between the cloud and on-prem, that's one of the projects we're working on. We are also working on Zeek, how to install it, how to use it, what are the signatures, packets, protocols. It's an open source project. So we're working with one of the lead developers that she's very smart, wicked smart on Zeek. So we have a lot of webinars, hands-on workshops coming up for that. We're bringing Kubernetes knowledge and education to our group as well, and we are doing hands-on workshops. Last but not the least, packet capture. So if you want to know more about packet capture, network sniffing, we also have a project for that. Again, if you want to know more about any of these projects, go ahead and send us an email or follow us on our social media. With that, I'll shut up and pass it on to Drew. All yours.
Thanks, Victor. Funny it ended with packet capture. We'll absolutely talk about packet capture a little bit today. As Victor introduced me, I'm Drew Ganther. I'm responsible for sales in the West for Medigate, the entire Western United States, as well as Canada. And with me, I have Simeon Atubor, who leads our pre-sales engineering team. And what we wanted to talk about with the next 23 minutes here is not Medigate, but the space that we live in. And what we see so often is this evolving landscape where a lot of healthcare systems just don't really know where to start or what the successful pieces of a program really look like and what those foundational elements need to be. So what we want to do is just take our experience in the space and share with you some of the key challenges and the ways that successful organizations have built a program around this, and really those foundational elements to a program level. So I'm sure everybody's well aware of the problem, but I put this slide up just to give you guys some stats on this. And of course, you can have this to take to your groups internally and help your conversations internally. But the big takeaway here is this pace of IoT adoption and acceleration is only going to increase. We've seen it over the past 5 years. It's only going to get more and more challenging. The patient room of the future is going to be more connected. There's more telemedicine. We're seeing a huge race to telemedicine now for obvious reasons with COVID. How do we keep up with this pace and make sure that the security elements aren't forgotten or they're not an afterthought, right? So few more stats for you that I won't bore you with, but bottom line is this problem is something that has been not ignored, but somewhat swept under the rug for too long. So what do I do about it? This is the framework that we really think there's 4 pillars that you really need to look at. And first, it's inventory. Now, what's challenging about inventory is you've got 2 groups that are responsible for this. Your network and security group, they need to know everything that's connected to the network, yes, but these network connected medical devices are not owned by IT or the typical reporting structure that security and network teams report up through. They're owned by biomed or clinical engineering or health technology management, ClinTech. There's a lot of different names for the group in different health systems that's responsible for managing the configuration and the maintenance of the devices that are most critical and that we're most worried about, the most challenged to address. So it's inventory and understanding a common bridge for inventory so both groups have the same view. Risk management. How can I effectively quantify the risk associated? We all understand there's risk here, there's vulnerabilities, there's outdated operating systems, there's all kinds of things that we know in context that it's there, but how do we quantify that and get really targeted to address that risk and minimize that risk? If you can't address the risk from a upgrade or a patch management perspective, how can I protect it from an exploitability perspective? How can I get really granular policies that match the criticality of if they were to be exploited? How do I get really granular with controlling access to these devices that I know are vulnerable? And then it's lifecycle management. So this isn't just let me make sure the device is maintained and the preventative maintenance schedules are adhered to, but how do I manage the onboarding and offboarding of devices? How do I assess the risk of a vendor or manufacturer in the medical space before bringing them onto the network? So the device lifecycle management is also a team sport where you really need cyber expertise as well as the clinical expertise to make these joint decisions as you decide what to bring onto the network. So when we talk about asset management, again, it's a team sport. It's something that both the clinical engineering team and the IT or security network team, the groups that need to come together need to have a common thread for visibility. Having MAC and IP addresses may seem like enough for some security teams, but then when they go to collaborate with the biomed team, for example, in the case of a security incident where you have an IP or some MAC address that has an indication of attack or threat or there's a breach or whatever's happening, and IT is speaking of it in terms of IP and MAC, and clinical engineering does not have IP and MAC logged in their system, it's hard to build a common baseline for where you are right now and what can you do in response without introducing clinical risk. When you can bridge the gap between maybe it's the serial numbers or the unique identifiers that clinical engineering uses and match them to those network identifiers that IT and security are traditionally used to using, now we can have a quick baseline to be able to effectively collaborate together. So visibility is not just knowing what's on the network from an IP and MAC perspective, and it goes deeper in understanding full context that everyone can relate to. So in that thread, as you go and look at how do I leverage technology that's available today to give me this visibility, there's two main approaches that you'll come across. There's DPI, or deep packet inspection, and there's statistical modeling methods like AI or machine learning. So both are effective in creating a full picture of the types of devices that are connected to your network. What deep packet inspection provides beyond what AI can do from a visibility and profiling perspective is the type of information that you can gain from the application layer. Things like serial number, application version, firmware version, things that may seem like they're more relevant for biomed and clinical engineering. But when you look at it in the context of needing to create a group that brings different types of expertise to the table to have a framework or a foundation for a successful program, we need to ensure that all parties are speaking the same language. Everybody has use cases that are being that drive value for them and motivate them to come to the table to be successful. So it's important to understand what deep packet inspection is and to what level deep packet inspection can be utilized to pull out attributes that have value in your building your program or feeding these attributes into other systems that you may be using for network control. Again, both are very successful in understanding what types of devices are on the network. Where DPI becomes more valuable is getting into individual devices, not a device type, but an individual unique identifier, higher level or deeper visibility into that device. This gives you sort of an example of what I'm talking about. So this could be considered visibility in some sense. You know, I know my IP, my manufacturer, it gives me a good idea, but bringing DPI into the equation and understanding the serial number, for example, to map to these, just a good graphic to kind of give you an example of what. So once I know what's on my network, I need to be able to understand risk. Again, this is a joint effort. I may be able to determine risk from how vulnerable is the device, how likely is that specific CVE to be exploited, or how exposed is it. But then I also need my clinical team to understand what's the impact of patient operations if that device is exploited, right? And that's part of the risk that we need to understand. It's not just from a network perspective, there's a patient care perspective as well. It needs to be a team sport. So what we're seeing be really successful here is we've seen a lot of clinical engineering or biomed background individuals start to really dive into the cybersecurity elements and start to get more mature with their understanding and language around cybersecurity. We need the same from the cybersecurity professionals, people with really deep understanding and deep backgrounds in cybersecurity and networking, to start understanding more of the operations on the patient care side and of the different types of devices that are being brought onto the network. So it really is a collaboration of helping each other build closer and closer to a common understanding on both sides. So we talk about this in the sense of cyber hygiene, clinical cyber hygiene, and it starts with inventorying every device, correlating the known vulnerabilities that we all have access to different vulnerability and threat sources, but correlating those to the devices that are on the network, understanding once I know that there's a vulnerability, can anything be done about it? Again, this is an area where it really needs to be teamwork, where you've got your clinical engineering team that can communicate with the manufacturers, get that list of vulnerabilities, bring it to the manufacturer, and understand, is there a patch available or not? And that's going to be really difficult to do from a cybersecurity team perspective if you don't have the engagement of the primary stakeholders and decision makers that buy all these devices and can put pressure on the manufacturers to start evolving what they do in response to cyber threats. We're seeing more and more of them. It's on the manufacturers as well to start evolving at a better, more rapid pace to keep up with what we're seeing in our connected clinical networks. So how do you do that? Again, it requires team members from both sides of the house to speak each other's languages, to get the right data, to go to the right sources, and to bring the whole industry up to address what we're seeing today. And then continuously evaluating this on an ongoing basis, whether that's before onboarding devices or what can I do given my existing environment. Once we understand what we can patch, what we can update, what we can address from a vulnerability perspective, we need to have expertise to be able to create policies that can be enforced on the network, again, to reduce exploitability. Not all the vulnerabilities can be addressed, so let's make sure they're not exploitable. This takes expert network expertise, right? You need people that are able to really understand the impact of your network control tools. You need clinical engineers to understand the flows and the network mappings that, maybe the technology that you're using is providing you, but being able to determine, is this policy the right policy? Is what we've put together here the best possible policy? Are we missing anything? Having that collaboration is going to be critical. So if you have the right team in place, then we've seen the most successful approach to really getting to a point where you can protect yourself from the threats associated with all these vulnerable medical devices. It is around network enforcement. Unfortunately today, the manufacturers at large, can't speak for every one of them, some are better than others, but they're not very fast to respond to new vulnerabilities that are coming out. That is not a challenge that is really in the hands of the HDOs and the healthcare systems. That's a bigger challenge. It's going to take a lot longer for that whole industry to change. We need to put pressure on them. We need to continue to get better, but you as a hospital stakeholder do not need to sit vulnerable while we wait for that to change. What we've seen most successful in the short term is driving all this visibility and data and collaboration between the teams into projects that you can really enforce policy and control communication around these devices. So only the necessary communications are allowed to happen. And this just gives you sort of a workflow of what we see there, of how to operationalize that visibility data into enforcement. So from a segmentation roadmap perspective, again, understanding the visibility, define the strategy. This strategy is so hard to do if you're doing it in a bubble with just cybersecurity or network, just your traditional IT security teams that are used to working together. If clinical engineering and biomed are not engaged and involved, the project will take longer to progress, and the outcomes generally are not going to be as successful as if you did have a clinical engineering or biomed stakeholder that has that deep expertise and understanding of how these medical devices are used for patient care operations. If you can build that team together, you can expect to see a lot more success and pace at which you can be successful in addressing the projects. But with those teams together, you're building your device profiles, you're designing your policies. Everybody has enough visibility on both sides of the house to understand, is the policy enough to really limit cyber risk? And is it within reason to not introduce operational risk? And then once everybody is on the same page, now you can really start enforcing policies and see some real gains from risk mitigation perspective. We're calling this, and to be determined if this takes off, but we've all heard of SecOps, DevSecOps. We're seeing this team as really similar in the approach that needs to be taken, and we're calling it clinical SecOps. So really what that means is just engaging clinical engineering, engaging the clinical teams that are in charge of managing this inventory early on in the process before you get too deep down what it is you want to do and find out that clinical engineering has some wrench that it will throw in, that whatever the plan was won't work for XYZ reason, or we can't operationalize that for XYZ reason. So having them engaged early on, just like having security engaged early in a dev cycle, we see way more success and way less rework on the plan and the scope of what a project's going to look like. So clinical SecOps, same concepts as DevOps and DevSecOps, just applied specifically to IoT and IoMT security. I talked about lifecycle management. Again, this is understanding as things change and understanding what you can and can't do from a upgrade and patch management perspective, but also when is it time to retire an old vulnerable device that there is no, it's not going to be upgraded. That is a glaring risk. And when you do that, what does my process look like for assessing risk of my new manufacturer or vendor that I'm going to choose to fill that operational need? Am I really looking into how that manufacturer operates from a cyber risk response perspective? How fast do they release patches? How aware are they with what they're building into the security of the device? And is that being effectively weighed out and considered as I'm making decisions on what to purchase and use in my hospital? So the other piece that's not really cyber, it is cyber related, it's not cyber heavy, but it's utilization. So understanding when your devices are most utilized so that if you can patch it, you can pick the appropriate time to take it offline and patch it. If you are in an incident response situation, understanding, is that medical device in use with a patient before I quarantine the device? And maybe I can quarantine the device, but understanding the network workflows that if I quarantine that device, am I disconnecting some connectivity that's required to continue delivering patient care? And if so, what's the patient impact there? So having that visibility into the utilization of the device and how it's communicating through the network, it can be really important for operational efficiency and just ensuring I'm operating with a lean fleet, but it's also important for cyber response and for patch management activities. And the rest of these, location and integration, I think are pretty self-explanatory. So how do you get support? How do you get your decision makers, the board, or whoever it is that needs to fund a project, to fund a new requisition for a clinical cyber specialist, for example, somebody that can be that liaison and bridge the gap? There's serious value for these projects. We all know the risk, and unfortunately it's been swept under the rug a little bit. We're seeing a huge turnaround in the past couple of years of the awareness and the support that hospitals are getting to create a fully baked program here. But this just summarizes it for you. There's a lot of value in knowing what's on your network, detecting the vulnerabilities, being able to protect it, where in the past, without automation around that and using, for lack of a better term, sort of the sneaker net approach for going out and manually identifying what CVEs are present, or manually trying to figure out, sifting through logs, how I can create a policy and trying to communicate between groups. That can be tough, right? So being able to invest in a technology that will automate that for you and then bring the different brain trusts together to take those insights and say, how do we really use this to lower risk and build ROI out of this? So that's very high level and quick, with the 30 or 20 some odd minutes that we had here. But to kind of summarize, I think what's needed is, first, just like what the FDA and what the FDA put out October 2018 with their medical device cybersecurity regional incident response preparedness playbook. And if you haven't read it, I recommend you Google that and take a look. But step one is getting an accurate and complete inventory of everything on the network. So get the full visibility, quantify the risks, build a team that can put their brains together from both a clinical technology management and a cybersecurity background, and understand how one affects the other, and build a bridge between those groups to be able to make fast and effective decisions on how to scope the program, how to build a program to address this. And then continuously monitor, and just like any other program that you're going to put in place, continually improve the program. Continue to try to build more governance and more policy into what you're onboarding onto the network. Continue to try to get additional avenues to put pressure on manufacturers to change their approaches. Meanwhile, tuning in your network control tools to be able to reduce the exploitability, even if the manufacturers are not being responsive with the vulnerability side of it. And I think these are really the keys to building a successful program.
Awesome. That was great, Drew. Thanks so much. one thing we have that we may need your insight. Can you speak to a little bit about remote medical assistance, how that has been increased given the situations, and what are the challenges that has brought it up to the industry?
Absolutely. Yeah. So, interestingly enough, this is an area where we were looking into how do we better, how do we have real impactful, measurable risk mitigation with telemedicine? And then this is over the past couple months been ramped up uh, a ton, as you can imagine. And I don't have a complete answer for you there as of yet, because this is so fast at the pace that everybody's trying to adopt. We can absolutely identify the telemedicine components that are being used to deliver telemedicine, and make sure you at least understand what's on your network, what's being used. That's step one. There's connections that are taking place that need to be encrypted. They need to be there needs to be security on those individual patient connections that the telemedicine platforms are absolutely addressing. But we know security happens in layers, right? So how do we ensure that the security that the telemedicine platform provider doesn't fall through the cracks, that there's not breaches to their security, and how do I put safeguards in place? So that's something that we could have a whole nother session on how we're doing that.
Yep.
But yes, there's a ton there. And I think it just starts with what's being brought onto my network. Your baseline is having this group to understand, what are we doing to deploy this? What are the different components? Let's accurately at least monitor the components of the system, and hopefully trust that the platform we're using has built-in security that's sufficient for baseline, but we know no one security layer is ever sufficient. So how do I then build upon that to better monitor for safeguards against, if theirs falls through?
Got it. Yeah. And again, probably this would be a good segue for our next session, and we could talk about it. So, any questions? One question we have: does your company have any open source tools? So, Drew, that's for you.
Can you specify what you mean by open source tools? The short answer is yes, many. But what do you mean open source tools that we give out to a community of users, or do we ourselves use open source tools?
I think community of users, that if you have any Git repo that you want to give it out to the community, do you have any open source tools to give it out?
We do not have open source tools to give out today.
Okay, something to
ask,
put on the agenda.
Yeah, that's an interesting ask. I'll run that up. We've had conversations around this for things like critical access hospitals that typically don't make money, and they're critical. The government funds them to make sure the population in that area has healthcare. So it's hard to go ask a critical access hospital to pay for a solution for security, right? But we know it's important nonetheless. So we've had preliminary conversations about that, and I appreciate you bringing it back up. There may be something coming there.
Awesome. One more question we have. So how do you protect legacy systems? They are not fancy, it doesn't have metadata, you can't get any of that information. So how do you protect legacy systems?
Yeah, it's a great question. So they're typically, legacy systems are not going to be auto-identified. So when you plug in a solution that does passive traffic analysis, whether it's AI or DPI, whatever it is, if it's not a known device and it's not in the database of known fingerprints, whether that's a network fingerprint or an actual, parsers for different attributes, we go through what's called a device hunt. So of course, you're going to see, if it's connected to the network, you're going to see IP and MAC, and you're going to say, okay, this doesn't fit a profile. We have a team of data scientists and network analysts that go through and understand, is this a protocol we've seen before? If not, this is where not to make this a commercial, but this is where Medigate really separates ourselves from our competition in being healthcare focused. It's not just the bigger database of known medical devices, it's the know-how on how to go dissect an undocumented protocol. So how do you go learn a language without a textbook, right? And this is what Medigate is really good at. And so we haven't come across any scenario where we can't go fingerprint legacy devices. It takes time. There's a whole nother effort there. That's not a plug and play right out of the box. You're going to see it and we're going to magically figure it out. There may be some clues and some some things that we need from our customer to help us understand exactly what it is. Once we have it, once we know we have the protocol awareness built in, we know what we're parsing to identify that device, now we can track it and track the behavior. And ultimately what we then do is, what is it used for? What is it talking to? What are the destination IPs, or what does it need to do? And then let's write a policy against it and ensure it can only do that. So now we know there's not going to be any upgrades. There's not going to be any security patches for this thing. But if we can get down as close to micro segmentation or zero trust or whatever marketing term you want to use for controlling the communications of that device so that it's not exploitable, now we're less concerned about how vulnerable the operating system or applications are.
Great, awesome. So one last question. Do you see any challenges with the regulations in this area?
Yeah, I do from a patch management perspective, and I do actually see a lot of healthcare systems ignoring that and still doing a lot of patching that's not necessarily approved by the manufacturers. There's a lot of trouble there from a support contract perspective. I'm not concerned about the regulations from the FDA perspective. I think that's a little bit of a misinterpretation of the FDA's guidance. And the FDA has come out in the past couple of years with quite a few pretty bold and clear statements that it is not the FDA that's trying to restrict patching or restrict any kind of updates to these devices. That is absolutely on the manufacturers. The FDA warns against the risks of applying a patch that's not tested and bringing a device back into operation, the patient risks there. But there's no regulatory restrictions as far as what you can do to patch a device. There's just processes that you need to go through to ensure it's safe to re-enter into operations. With that said, I don't think that patch management is the best approach right now. I think the best approach is network control. And if you're allowing the device to do exactly what it's designed to do, but nothing more, then we aren't getting ourselves into this convoluted, complex question of regulations. What can you and can't you do to the device? We're allowing it to do what it's designed for, but only. So by doing network control, we're removing that concern.
Got it. So how do you handle the devices or communication happening once in a while? So you won't be able to get enough data, or you won't have enough sampling. It only happens once in a while. How do you fingerprint those devices in controlled hospital environments?
That's a great question. And yeah, not all packets are created equal, right? So if we don't have enough sampling, the answer is we don't have enough sampling. So I can't speak to every solution. I know a lot of different solutions will have like confidence scoring and different things that it's kind of hard to interpret. With Medigate, we are definitive. So everything that we show on our dashboard is not probabilistic, they're deterministic. So if there's limited amount of traffic giving us limited attributes about a device or limited ability to fingerprint it, we're only going to show it at the degree that we know to be true. So the answer to your question is like it may not necessarily be the solution to the problem, but we will at least show you that it's there and show you that we don't know enough about it. And that will be a small percentage of devices. So we're at least narrowing down, where do I start? Once I've built this group of clinical tech management people and cyber people and network people, now the question is, okay, where do we start? What you're asking about of these devices that have very limited communication will be a smaller percentage.
Right.
You'll address it differently, yes. We'll give you at least enough to sort of prioritize what's next. What more do we need to do? But yeah, that's a good question, and there's no silver bullet. We don't want to scan those devices. There's different approaches. You can actively scan them, a really tailored, specific scan once we have an idea of what it is, when is it used, when is it safe to do this, how do we do this in a controlled manner. We can take that sort of approach. There's different ways to do that, but it's not an automated, overnight solution in that sense.
Got it. All right, folks, that's all the time we had for today. So I'll continue talking about the next events and final slide. I hope this was helpful for everyone. And if you have any questions for Drew, we can continue this chat, send us feedback. Session is recorded. It will be put on our YouTube. You can watch it, review it later on, and provide us feedback. So about our next event, on May 7th, we're going to talk about how to connect and scale remote workforces. That's a timely discussion. We should have it right now. We're also going to talk about IoT security, and that will be focused more on vendor side, what they have to do before even ship out their IoT devices, for example, fridge or microwave or whatever they are doing it. So it's more on the commercial IoT security. Then we're going to talk about testing as a career. So if you're looking into getting into some sort of QA testing or some sort of other testing, what are things you should consider? What are the open tools that you should learn before getting into that? Speaking of open tools, as you know, we also have a project coming up for Zeek for Home Lab. So on 21st of May, we're going to talk about how to set up Zeek for your home lab. What are the different things you should consider and learn about Zeek? With that, let's go to the next slide. So if you want to know more about any of these events, you want to register for it, go ahead, scan the QR code, follow us on Twitter, LinkedIn, YouTube. All of these recordings are being posted on our YouTube channel. All of these information about the sign up are being posted on our LinkedIn, Twitter. If you have any specific questions about any of the projects we are doing, please feel free to drop us an email or give us a call. With that, thank you so much, Drew. Thank you for having us. And it was a great presentation.
Thanks for joining, everybody.
Thank you.